Hi, this is Mr. Lee. This video is on factorization of linear expression and is meant to be a sequel to the video on algebraic expansions. So just a simple recap of what we have dealt with in expanding algebraic terms. Here we have A multiplied to a sum of B and C, and in expanding things out, you just multiply A to both B and C and add it up. This is what we have dealt with in expanding. In factorization, on the other hand, we do the reverse, namely, given a sum of AB and AC, with a factor in common of A, you take A out of the picture. And what is left is the sum of B and C, and you multiply this by what you have taken out, which is A. This is actually what we do in factorization, which is to express a sum of terms as a product of terms. So, but as an example, if you look at part A, you have 8x plus 18y. Notice that each of these terms, they have a common factor of 8. So if you take out 8 from both of the terms, what is left will be x and 2y, and you sum them up within this bracket. You can check that your answer is correct by expanding it and see. B is a little bit complicated, where you have 6abc plus 18ab squared minus 12a squared b. Just a quick glance and you can observe that each of these terms has a factor of 6, a, and b. So if you now take out that from all these three terms, what's left inside will be C from the first term. The second term, if you take out 6ab over here, you will be left with 3b. The third term, well, there's a 12. So 12 take out 6, you get 2. A squared b, if you take out ab, you are left with a. And with that, that is the end of the factorization. This is level 1. In level 2, what we do is slightly more complicated, and we call this a grouping process, where you have things of the form ax plus bx plus ky plus kby. What you do over here is you group them 2 by 2, and each of them you notice that there is a factor in common. For instance, the first two terms, there's an x term in common. You can take that out. For the next two terms, there's a ky in common, and that you take out as well. So once you have taken them out, you'll be left with a sum of two terms. And now you notice that from these two terms, each of them has a multiple of a plus b, and that you take out as well. So from something complicated of a sum of four terms, you are now able to express it as a product of two terms this way. Okay, we'll just look at a few more examples here. In part A, you have h minus 2k plus hk. Same thing, you group them 2 by 2. So here, this becomes h minus 2. So for the third term, there's a minus sign. If it's complicated looking, you put the hk in front, and then minus 2k at the end. So the first two terms, nothing to factorize out, not to worry, just leave it aside. The next two terms, there seems to be a k in common. So let's take that out. And that leaves you with h minus 2. And now as you do so, you realize that there is now a h minus 2 in common for both terms. You take that out again. So if you take out h minus 2 from the first term, you'll be left with 1. If you take out h minus 2 from the second term, you'll be left with k. And that's it for this factorization. Same thing goes for part B, group them 2 by 2. So the first two terms, well, I see a 2a as a common factor, and factorizing it gives me a b minus 5c at the end. The next two terms, there's a common factor of d, and if you take that out, that will be 5c minus b. Okay, looks very different, but these two guys are actually negatives of each other. So I'm going to write the second term. I'll express it as b minus 5c. At the same time, that changes the sign to a minus sign. In other words, I so-called take out a negative sign. And with this as a common factor, this is now b minus 5c, and we will be left with 2a minus d after the factorization. And yep, that's the end of this factorization. So that's the end of this video. Hope you found it useful, and we'll see you in the next video.